Okay, so today we are going to be graphing rational functions. So, direction, state, graph each rational function, give the asymptotes, and state the domain and the range. So, remember that vertical asymptote, you are going to set the denominator equal to 0. Okay, that's the denominator equal to 0. Okay, horizontal asymptote is the one where you have to check the degrees. Okay, and we'll talk about which is what. Okay, so if I set the denominator equal to 0, then my vertical asymptote is going to be x equals 3. My horizontal asymptote, I'm going to check the degrees. Since the degree is 1 and the degree is 1, you have to go to the leading coefficient. So the leading coefficient here and the leading coefficient here are both 1, which means that my horizontal asymptote is going to be equal to y equals to 1, because you're going to do 1 divided by 1. Anytime that the degrees are the same on the numerator and the denominator, you go to the leading coefficients and you divide them. So my horizontal asymptote is going to be y equals 1 divided by 1. Okay? So let's graph both of those. So we need to show a vertical asymptote at 3. And we need to show a vertical asymptote at y equals 1. I'm sorry, a horizontal asymptote at y equals 1. Now, since we're only working with positives today, we'll figure out negatives another day. They're going to be in the top right quadrant and the bottom left quadrant. And all you're going to do is mimic the shape of the mother function, which is those two quadrants. So when you look at your domain is going to be the set of all reals where x cannot equal 3. So at 3, it's not going to be equal to. The other way of saying this would be negative infinity to 3 union 3 to infinity. So you can write it either way. We taught you in class today that now you can put the reals with x not equal to 3, or you can use interval notation like you've been used to the whole year. My range is going to be all the reals again, except y cannot equal 1. So make sure you put a slash through the equal sign. You could also write negative infinity to 1, union 1 to infinity. So either of those notations are going to be accepted. Number 2, our vertical asymptote is going to be where x plus 5 is equal to 0. So this is going to be x equals negative 5. And then my horizontal asymptote, I'm going to check the degrees. The degrees are both the same. They're both 1. When they're the same, you go to the leading coefficients, which are both 1 again. So my horizontal asymptote is going to be y equals 1 divided by 1. So this is going to be y equals 1. So at y equals 1, I have a horizontal asymptote. And at x equals negative 5, I have a vertical asymptote. And then again, I'm going to mimic the mother function, or the parent function, and it's going to be in the top right and the bottom left quadrants. So my domain is going to be the reals where x cannot equal negative 5, and my range is going to be the reals where y cannot equal 1. Okay, number 3. For my vertical asymptote, I have to set the denominator equal to 0. Okay, so this is going to be 4x equals 8, and so x is going to be equal to 2. So I have a vertical asymptote at x equals 2. If I look at the degrees again, they're both 1. So for my horizontal asymptote, I'm going to have to go to the leading coefficients, which is 1 over 4. So my horizontal asymptote is going to be at y equals 1/4. So at x equals 2, I have a vertical asymptote. And at y equals 1/4, I'm going to make that kind of right near the x-axis, I have a horizontal asymptote. And again, I'm going to mimic the mom. So when you go to write your domain, it's the reals where x cannot equal 2, and it's the reals where y cannot equal 1/4. Pretty easy. All right, number 4. So for a vertical asymptote, I'm going to set the denominator equal to 0. So 4x is equal to 6. When you divide by 4, you get 3/2. So my vertical asymptote is at 3/2. My horizontal asymptote, again, we're going to go to the degrees, which are both the same. So it's going to end up being 8 divided by 4, which is going to be a horizontal asymptote at 2. So at 2 we have a horizontal, and at 3/2 we have a vertical, remembering that 3/2 is about 1.5. Mimic the parent function. And so my domain is going to be everything, all the reals except x cannot equal 3/2. And my range is all of the reals except y cannot equal 2. And we're done.